So in this section, we're going to talk about chemical equations and balancing them. So why is a chemical equation important? It's because it tells us exactly what has taken place when two substances react or change. The chemical equations tell us exactly what the substances were made up of initially and what they're made up of in the end. In a chemical equation, we have the reactants on the left side, as you can see. That's what we started out with. If we have more than one reactant, those are always separated with a plus sign. It's not a mathematical plus, literally it stands in place of the word and. On the right-hand side, we have the products, and those are the things that are produced or what are there at the end of the reaction. So balancing a chemical reaction always involves something called conservation of atoms. We must have the same number of atoms of each type on either side of the equation. We cannot create atoms, we cannot destroy them. All we can do is rearrange them into different substances. So to do that, we change what are called the coefficients on each of the substances. And the coefficients are the numbers in front. So if we have water, which is H2O, I could put a coefficient of 5 on it and say that we had 5 H2Os. We can't change the subscript or any of the indications of how many atoms are in that molecule, because that would actually change the molecule itself. What do I mean by that? Well, if we take a look at the formation of water, we have H2, which is hydrogen gas, O2, which is oxygen gas, forming H2O, which is water. This equation isn't balanced because, as we can see, the subscripts tell us we have 2 hydrogen atoms in that molecule on the left. We also have 2 hydrogen atoms in the water molecule on the right. So that's okay. But we also have 2 oxygen atoms on the left, but only 1. And if we don't have a subscript, that means we have 1 atom. So that isn't balanced. We've gone from 2 oxygens to 1. The easy way to do it, and what a lot of people think to do, is to change it into H2O2. That would definitely balance off the oxygens, but H2O2 isn't water. H2O2 is hydrogen peroxide. Vastly different substance. Water, we drink, we use for many different things. Hydrogen peroxide, it's a potent disinfectant. If you pour it on a cut, it bubbles. It's also used for hair bleaching, and water won't bleach your hair. So it's a completely different substance. What we do, however, is we change the coefficients. And if we have 2 hydrogen molecules and 2 water molecules, this would then balance. Why? The 2 H2s mean we have 4 hydrogen atoms on the left, and we have 4 hydrogen atoms on the right with 2 H2O. O2, we have 2 oxygen atoms on the left, and this 2 coefficient on the right also applies to not only the hydrogen but the oxygen. So it means we also have 2 oxygen atoms on the right. There is also understood to be a 1 coefficient on the oxygen, just so that we have that all balanced. Now, we don't have to necessarily balance this in a 2-1-2 coefficient scheme. We could, in fact, balance it as 4-2-4. In this case, we'd have 8 hydrogens on each side and 4 oxygens, but this isn't totally properly balanced. Since the 4, 2, and 4 can actually be divided by 2, this isn't completely reduced. And when we balance a chemical equation, it's customary to reduce it. So that's why we go with the 2-1-2 scheme on the last slide. So what you're going to see is a skeleton chemical equation with no coefficients, and it'll be your job to balance it. How do you do that? Well, it's a little bit of an art and a little bit of a science, but there's a few steps that you can follow. Number 1, the more often an element appears, the later on you should try to balance it. Chances are that all the other elements that appear once or twice will help to balance off those elements that appear multiple times. Number 2, it's always best to balance large molecules first. Once we get those balanced off, the smaller ones are easy to deal with. And we always balance atoms of elements last. An element is just an element by itself. Because if we need to change the coefficient on an element, we can do that without changing the number of atoms of anything else.